this is 2.6, and they gave us a PDF, but it had an A in it, so we're trying to figure out what A is to make it a valid PDF, which means you integrate the PDF and set equal to 1 to see what A is. Let's see, so we've just been simplifying, and I'm going to add that 0.5 and change that minus, so we have negative x squared plus 0.5x plus, let's see, 0.5 minus 0.0625 is 0.4375 dx. Now, if you have a fancy calculator, you probably could have put it all into your calculator here at the very first step. If you're doing it by hand, then you want to simplify a little bit first. So now let's actually integrate. So negative x squared, you'd raise the power and divide by your new power. So plus 0.5, and then this x, it was a power of 1, so we'll raise the power by 1 and divide by our new power, plus 0.4375x. So you integrate just the constant, it becomes 0.4375 times x. And we'll evaluate that from x equals 0.125 to 0.5. So that means you'll plug in the 0.5 first, so negative 0.5 cubed over 3 plus 0.5 squared. Oh, that's 0.5 times 0.5 squared over 2 plus 0.4375 times 0.5 minus, and this A is still completely all on the outside. Then we'll put in the 0.125. So negative 0.125 cubed over 3 plus 0.5 times 0.125 squared over 2 plus 0.4375 times 0.125. So it looks like we're good here. Okay, so we did integrate. I know this is a lot of calculations, okay, but with all of the integral stuff, that all worked out finally to 0.1816. This is probably one of the hardest parts of the assignment, is just doing that massive integration. Okay, so we got A times 0.1816 is what we get when we integrate the PDF. But that's supposed to be equal to 1. So let's set that equal to 1. And solve for x, or solve for A. So we'll do A times 0.1816 equals 1. So A would have to be 5.506. Now, depending on where you round or how much you round, I think the textbook got 5.504. That's just a rounding difference. That shouldn't be a big deal. And let's see, so part A said find A. It also wanted us to sketch the probability density function. So we just went to Wolfram Alpha and we plotted it. We said plot or graph. Here's our function. It's from 0.125 to 0.5 and just 0 everywhere else. And so then you would just sketch a picture of that back on your actual sheet. And so we've drawn in our PDF. And so that part's not too bad. I guess I should write in what my full PDF is now. So little f of x equals 5.506 times our 0.5 minus x minus 0.25 squared. For x between 0.125 and 0.5. Again, that one was kind of a pain algebraically, but you get there eventually. And B says find the CDF. So how do we always go from PDF to CDF? And at this point, I know we don't have all the formulas memorized, but hopefully this part is sinking in. PDF to CDF, we have to integrate. So we want to integrate, and they say start at negative infinity, but really in this problem we only care about from 0.125, and we'll integrate up to x. And you're supposed to use a dummy variable. So 5.506 times 0.5 minus, we'll put in a t, minus 0.25 squared dt. Again, if your calculator can do it, doesn't give you an error when you try and put an x and an x here, you can forget the dummy variable part, but otherwise we'll try and remember to use that. And so my calculator did go ahead and give this to me, but it's kind of long. If you needed to do it by hand, you could do it. It's going to be the exact same thing as what we did up above almost, except for instead of an a, we have this 5.5, and we have an x for our upper limit. But we get negative 1.835 times x cubed minus 0.75 x squared minus 1.3125 x plus 0.174. And part C says, what is the probability that the paint thickness is less than 0.2? So we're looking for the probability that x is less than 0.2. You could use the PDF or the CDF. We'll probably just use my CDF, so I don't have to integrate again. So we're just looking for f of 0.2. So all I have to do is plug 0.2 in up above. So go ahead and plug it into your CDF. And so after plugging in, I got 0.202. So that's our probability. And even though, again, our CDF didn't look like the book CDF, it's just an equivalent form, we did get the same probability.